Hi, my name is Robin and you are welcome back to my channel. In this video, I will be solving lots of examination questions, tricks, and the best way to get your solution. So let's dive right into it. So we have a question. If P and Q are the roots of f of x squared minus 4x minus 14x plus 45. We are asked to find the value of, so we are looking for value of 1 over p plus 1 over q. Okay, the first thing we need to know is that here 1 over p plus 1 over q is something as the LCM is pq, that is p times q, which is pq, q times 1, that is q, and p times 1, that is p. So here is something as p plus q over pq. And remember here, we're told that p and q are the root of the equation. So if p and q are the root of the equation, and we're asked to find the value of that. So remember that alpha plus beta, which is the sum of root, is minus b over a. Alpha beta, which is product of root, is c over a. So here, alpha plus beta, remember alpha and beta are the root of the equation. But in this respect, rather than saying alpha and beta, we are given p and q. So it simply means that p plus q is our sum of roots, which is b over a, and alpha beta, which is our pq, is the product of roots. So now all we need to do is find a, b, and c. From this equation here, okay, from this function here given to us, I can decide to tell you that ax squared plus bx plus c is equals to 0 can be compared to x squared minus 14x plus 45 is equals to 0. So my a here will be my 1, x is x, so b is minus 14, and c is 45. So our a is equals to 1, our b is minus 14, and our c is 45. So here I have p plus q as minus b, so that is minus, what is minus b? What is b? Minus 14 over a is 1. Okay, so minus 14 times minus 14 times minus is 14. 14 divided by 1 is 14. Then the next one is c over a. C over a, c is 45 and a is 1, so this is 45. But now, since we are required to find 1 over p plus 1 over q, and 1 over p plus 1 over q is same thing as p plus q over that. So here, what we have, what is p plus q? P plus q, we got 14, which is this one here, divided by pq, we got 45, which is that. So our option here is 14 over 45, which is 2, which is this one here. So let's go to the next question. Now, let me show you the best way you can solve the question that we just finished solving. Remember, you were told that p and q are the root of the equation. So if p and q are the root of the equation and you are asked to find 1 over p plus 1 over q, which simply means the sum of the reciprocals, okay? Remember, reciprocal of p is 1 over p, reciprocal of q is 1 over q, and you're asked to find their sum. In that case, whenever you have a question like that, all you need to do here is to apply using minus b over c. Here, I have minus. What is our b? Our b is minus 14. And our c is plus 45. So minus times minus plus, that is 14 over 45. So our answer is 2, which is still the same thing that we got for the first solution. So that is the best way you have it. Whenever you are asked to find the reciprocal, the sum of the reciprocal of the roots. For an example, if I have something like this, f of x is equal to 3x squared plus 5x minus 1. Now here, you're asked to find 1 over alpha plus 1 over beta. And you are told that alpha and beta are the roots of the equation. So in this case, I will just say using minus b over c. Okay? Minus, what is our b? Our b is plus 5. This is 5. And what is our c? Our c is minus 1. So minus cancel minus, that is plus. 5 divided by 1, that is 5. That is that. Easy. It works every time. In as much as you are told that the root of the equation are given as alpha beta, and you're asked to find the sum of the reciprocal. So let's go to the next question. Now let's take the next question. If alpha and beta are the roots of x squared minus x plus 1 is equals to 0. So alpha and beta are the roots. Okay? Then the value of alpha over beta squared plus beta over alpha squared is equal to. So that is what we are looking for. So in this case, I can just find the LCM. Okay? So this is alpha squared beta squared. This is alpha raised by 3 plus beta raised by 3. So this is something as saying alpha raised by 3 plus beta raised by 3, then alpha beta all squared. Okay, so what we need to recall is that alpha plus beta is minus b over a, and alpha beta is c over a. So here, let's get our a, let's get our b, and let's get our c. So x squared minus x plus 1 is equal to 0. If I compare with this general quadratic equation, you will see here that my x squared is my x squared, which simply means my a here is 1. So a is equals to 1. My x is my x, so my b is equal to minus 1. So b is equals to minus 1, and my c is equals to 1. So I've gotten my a, my b, and my c. So in this respect, I can get the denominator, which is alpha beta squared. So alpha beta all squared is equal to alpha beta is c over a. So what is c? 1 over a, 1 all squared, and that is 1. So the next thing that we need to get is alpha raised by 3 plus beta raised power 3. And recall, there is a formula that I gave for this in my previous video. For those of you that have not seen it, click on the top right hand corner to see the video. So the formula says that if I alpha raised by 3 plus beta raised by 3 plus or minus is the same thing as alpha plus or minus beta bracket alpha squared minus plus alpha beta plus beta squared. So now, so here I will just give you the formula so we don't have to waste time. So this will be alpha plus beta, and this will be alpha plus beta squared minus 3 alpha beta. That is if this is plus. If it is minus, I will also give you the formula alpha plus beta squared minus alpha beta. So now in this case we have plus, okay, so we can quickly get that alpha cube plus beta cube. is this. Alpha plus beta, that is minus b, that is minus b over a, which is this. Alpha plus beta, minus times minus plus. So definitely have 1 squared here because of this squared, because alpha plus beta is 1. Minus 3 bracket. Alpha beta is c over a, that is 1 over 1, which is 1. So this is 1 minus 3, that is minus 2. But here in our question, we are looking for alpha cube plus beta cube over alpha beta all squared. So alpha cube plus beta cube is already minus 2, which is what we got, divided by alpha beta is c over a, which is 1. So 1 squared is 1. So minus 2 divided by 1 is minus 2. So here our option is option 3, which is minus 2. Now in this question, if the root of a quadratic equation ax squared plus bx plus c is equal to 0, the roots are alpha and beta. We're asked to find the value of 1 over alpha plus 1 over beta all squared. Remember, I told you, if alpha and beta are the root of the equation, and you're asked to find the sum of its reciprocal, this is reciprocal of alpha, reciprocal of beta, I told you we can use minus b over c. Okay? But now, because everything here now is in square, you can see square, so that simply means I'll just put this one square. So here, minus, what is my b in this expression? It is still b over, what is my c? My c is still c. Okay, so I'm squaring this one square, so that will be minus squared is plus, so b squared is b squared, c squared is c squared. So my answer here is going to be b squared over c squared, which is option 4. Now in this question, if alpha and beta are the roots of the equation x squared minus x minus 1 is equal to 0, so alpha and beta are the roots, then the equation whose roots are alpha over beta and beta over alpha is, okay, the first thing here is that we get our a is 1, b is minus 1, and our c is minus 1. Here, alpha plus beta is minus b over a, that is minus 1 over 1, that is 1. Alpha beta is c over a, which is minus 1 over 1, that is minus 1. So here we're asked to find the equation whose roots are alpha over beta and beta over alpha. Remember, when you are constructing a root of, even when you are constructing a quadratic equation using roots, you use this formula, variable square minus sum of roots variable plus product of roots is equals to 0. Okay, so what is our variable? You can say our variable is x minus sum of roots. Sum of roots simply means these are the roots, right? So what is the sum? So here the sum is alpha over beta plus beta over alpha, then variable x, plus product of roots. In this case, the product is going to be alpha beta times beta over alpha is equals to 0. So let's find the value here. So now we can easily get this one here and get this one here. Let's quickly do that here. So alpha over beta plus beta over alpha, that will be alpha beta, alpha squared plus beta squared. And this is alpha plus beta all squared minus 2 alpha beta all over alpha beta. That is for this. Then for this, which is the product, so alpha times beta over alpha. So this will be alpha beta over beta alpha, which is still the same thing. So this we cancel this one, so that will be 1. So now we can say alpha squared plus beta squared over alpha beta, which is this one, and we said is equal to this, alpha plus beta. Alpha plus beta is 1 and is squared, so 1 squared minus, which is this minus, 2 bracket alpha beta is minus 1, okay, all over alpha beta is minus 1. So this is 1 minus times minus is plus, that is 2 over minus 1. This is 3 over minus 1, which is minus 3. So for this, we have gotten minus 3. So now let's put it in this formula so we can derive our quadratic equation. So our variable is x, so x squared minus sum of roots, we got minus 3 variable x plus product of root was 1 is equal to 0. So this is x squared, sorry, not cube. So this is x squared minus times minus is plus, so 3x plus 1 is equal to 0. So this is our answer, and that is option 4. Now the next question, quadratic equations corresponding to roots is, so we have the roots. Roots are 2 plus root 5 and 2 minus root 5. These are the roots. So this is like having alpha and beta. Okay, so they want us to find the quadratic equation. So that is construction of quadratic equation using its roots. So here, let's get sum of roots. Sum simply means 2 plus root 5, you add it to 2 minus root 5. 2 plus 2, that is 4. Plus root 5 minus root 5, that is 0. Then product of roots. Product of roots simply means we multiply 2 plus root 5 is multiplying 2 minus root 5. Okay? You can just use this. This is the easiest way to multiply when you have plus and minus. This is 4 minus 5. So that is minus 1. So remember, we use variable squared minus sum of roots. Variable plus product of roots is equal to 0. Now, what's my variable here? The variable in the option is x, so we already know variable is x. So x squared minus sum of roots, that is 4, which is what we got here. Variable x plus product of root, that is minus 1, which is here, is equal to 0. So x squared minus 4x minus 1 is equal to 0. So our option here is option A. Now the next question, if 3x squared minus 8x plus 6 is equal to 8x squared plus 2x plus 2 has only one repeated solution, then the positive integral solution of A is. Now, when you have only one solution, that simply means they are talking about equal roots. Okay? Which simply means alpha and beta are equal, they are the same. So that is only one root, only same number. So in that case, for equal root, discriminant is equal to 0. Discriminant is equal to 0. For those of you that have not seen my video on this, click on the top right hand corner of this video. And when you're talking about discriminant, it's the same thing as saying b squared minus 4ac. So that is equal to 0. So in this case, b squared is equal to 4ac. So this is the formula we are going to use. Okay? So now, let's put this in form of ax squared plus bx plus c is equal to 0. So I have 3x squared minus ax plus 6. Let's bring all this to the left hand side. So minus ax squared minus 2x minus 2 is equal to 0. Okay, so this is 3x squared and this is x squared, right? So minus ax squared, okay, then minus ax, then which one with the x? Minus 2x plus 6 minus 2 is equal to 0. Here, x squared is common, so this is what we have, 3 minus a. Okay, minus here, x also is common there, so I bring x, so this is a plus 2. So plus 6 minus 2, that is plus 4, is equal to 0. So I can now compare, okay, ax squared plus bx plus c is equal to 0. So we can get abc. So x squared is x squared. So my a is 3 minus a. X is x. So my b is minus bracket a plus 2. Then my c is equals to 4. So in this case, we apply this formula, b squared. So b squared 4ac. My b is minus bracket a plus 2 squared is equal to 4 times a is 3 minus a, then c times 4. So if I open the bracket here, a squared plus 4a plus 4, if you open the bracket, this is 16 bracket 3 minus a. So this is a squared plus 4a plus 4. This is 48 minus 16a. We can take everything to the left hand side. A squared plus 4a. Bring plus 16a to this side, that is plus 16a. Sorry, bring minus 16a to this side, that is plus 16a. Plus 4. Bring 48 to this side, that is minus 48, is equals to 0. So here we can rewrite this as a squared plus 20a minus 44 is equals to 0. So now let's solve this quadratic equation. Here I cannot use factorization method. I have to use the quadratic formula method. And I've done this in my previous video. For those of you that have not seen that video, click on the top right hand corner of this video. So I will be using a is our variable because that is a is equals to, let me say a, let me put it like this so that we can differentiate it from the a of quadratic formula. So minus b plus or minus b squared minus 4ac. You can see the formula has a and I want to differentiate it from this a. That's why I'm putting this bar over 2a. So here, our a is the coefficient of a squared, which is 1. Our b is the coefficient of a bar, which is 20. And our c is minus 44. So what I have here is minus, which is this minus, b is 20 plus or minus square root of b squared, that is 20 squared, minus 4 times a, what is a? 1, and what is c? Minus 44 over 2a, that is 1. So minus 20 plus or minus 20 squared, that is 400, that is 20 times 20. Minus times minus, that is plus. 4 times 1, 4 times 44, that is 176 over 2. So this is minus 20 plus or minus 400 plus 176, that is 576 over 2. And this is same thing as minus 20 plus or minus square root of 572, that is 24 over 2. Remember, I can change this back to a now since we made it that. So this is minus 20. I can say plus 24 over 2, or minus 20 plus, minus. In this case now we use minus since we already used plus. 24 over 2. So here a is equal to minus 20 plus 24, that is 4. 4 divided by 2, that is 2. Minus 20 minus 24, that is minus 44. Minus 44 divided by 2, that is minus 22. Okay? So here, in our question, they told us that it has to be a positive integral solution. So positive number for a. And the positive number for a here is 2 because this is negative. So our option is option 2. Now, let's see the fastest way to do this. In doing this, we are going to be using the option as the value of a. So the first option says if a is 3. So let's say a is 3. So I'll put a in the expression. So this is 3x squared. Let's bring this one here. Minus 3x squared is minus 3x. Bring this one here. Minus 2x. This plus 6. Bring this one here. Minus 2 is equal to 0. So this, we get this out. So what do we have? Minus 5x plus 6 minus 2 is equal to 0. You can see this one is no more a quadratic equation. So a cannot be 3. Now let's use 2. So 3x squared minus a is 2. 2x plus 6 is equal to 2x squared plus 2x plus 2. So this is 3x squared. Let's bring 2x squared here. Minus 2x squared minus 2x. Let's bring this one here. Minus 2x plus 6. And let's bring this one here. Minus 2 is equal to 0. So this one is x squared minus 4x plus 4 is equal to 0. If I factorize this one, x here, 2 minus minus. So x is equal to 2 twice. And remember, they said that this, if this is equal to this, has one repeated solution. And when we use a, we got one repeated solution because it is x equals to 2 twice. So definitely a is equal to 2. Now, next question. 1 root of the equation 5x squared plus 2x plus q is equal to 2 is reciprocal of the order. So they are telling us that if the root of the equation is alpha beta, for an example, okay, and they said one of these roots is the reciprocal of the other. So let's say alpha is the reciprocal of the other. The other is beta. So what is the reciprocal of beta? 1 over beta. So that will be alpha. Okay, so in this case, our root will now be, what is alpha? Alpha is 1 over beta, then beta. So this is our root now. Okay, So here we can say 5x squared plus 2x plus q. Let's bring this to the other side. So minus 2 is equals to 0. So let's compare with ax squared plus bx plus c is equals to 0. So our a will be 5, our b will be 2, and our c will be q minus 2. So we can say, remember that alpha plus beta, which is sum of roots, is minus b over a, and alpha beta, which is product of roots, is c over a. So in this case, if I look at alpha beta, what is alpha beta? Alpha already is 1 over beta, right? Because it's here. This is with beta here. So alpha beta is 1 over beta with beta is equals to c over a. What is c? Q over 2 over a, that is 5. Okay, alpha beta, that is, beta, we cancel this beta, so we have only 1 here. So q minus 2 over 5. So this will be 5 times 1 is equals to q minus 2. So 5 is equals to q minus 2. So my q is 5 plus 2, which is 7. But this question says, what is the value of q squared? So q squared will be 7 squared, and that is 49. So our option is 3. Option 3. Hi, the next question. The root of the equation ax squared plus x plus b is equal to 0. So the question says the root of the equation ax squared plus x plus b is equal to 0 are equal if. Now, the root of a quadratic equation is said to be equal when the discriminant is equal to 0. So the discriminant d is equal to 0. And discriminant means b squared minus 4ac. So, and this is equal to 0. So b squared will be equal to 4ac. So 2 roots are said to be equal. 2 roots of a quadratic equation are equal when b squared is equal to 4ac. So here, let's compare this one with ax squared plus bx plus c is equal to 0. So my a is still my a, as you can see from here. My b is 1, you can see 1, and my c is my b. So let's use this formula here and put our value. B is 1, so 1 square is equal to 4, a is a, and c is b. So 1 is equals to 4ab. So in this case, our option, if I divide through by 4, so this is 1 over 4 is equal to 4ab over 4. So here, a is ab is equals to 1 over 4. So our option is option 4. Now, next question. One of the roots of the equation x squared minus 12x plus k is equal to 0 is x is equals to 3. So one of the roots is x is equals to 3. So we're asked to find the other root. Whenever you are given one root and you're asked to find the other root and you have the quadratic equation, you just need to substitute the value of the root that you have in the quadratic equation to get the constant value, then you factorize or you solve using quadratic formula. So x is one of the roots, so x is equals to 3. So I will say 3 squared minus 12 bracket 3 plus k is equals to 0. This is 9 minus 36 plus k is equals to 0. 9 minus 36, that is minus 28. Sorry, minus 27. So minus 27 plus k is equals to 0. So k is 27. So I've gotten k as 27. Now let's put the value of k back to this equation. X squared minus 12k 12 plus 12x 12x plus k is equal to 0. Now we've gotten k to be 27, so I'll put 27 here. So now we can factorize this. X is here, 9, 3, minus, so x is equal to 3 or 9. So you can see the root of the equation is 3 or 9, and we are given the first one to be 3, so the next one is 9. So the second root is x is equals to 9. So that is option 2. Now the next question, find the equation whose roots are, so we have the roots are 2 over 3 and minus 1 over 4. Remember, we can use the roots to construct the quadratic equation, and that is saying variable square minus sum of roots, variable plus product of roots is equals to 0. Because in the options, the variable here is x, so we can use x. But now let's first get sum of roots. Sum simply means 2 over 3 plus bracket minus 1 over 4. That is 2 over 3 minus 1 over 4. Okay, so this is 5 over 12. Okay? Then product of roots. So that means 2 over 3 times minus 1 over 4. This is minus 2 over 12, which is minus 1 over 6. So let's put the sum of roots and the product of roots in this equation that we have. Okay, variable squared is x, so x squared. Sum of roots, we got 5 over 12. Then variable x plus product of roots, we got minus 1 over 6 is equals to 0. So x squared minus 5 over 12x plus times minus is minus 1 over 6 is equals to 0. We can, in this case, multiply through by 12. So this is 12x squared minus 12 cancels 12, that is 5x, minus 6 and 12, that is 2. So we are going to have this if you multiply through by 12. So our option here is option A. No, not A. We can't pick any option here because we have minus minus. And as far as I see here, we don't have any minus minus anywhere. So I'm not going to pick any answer here. So we are not picking any answer here because it's not in the option, but we can confirm that we are correct. So to confirm, let's factorize this. This is 12x squared minus 8x plus 3x minus 2 is equal to 0. So what is common here? 4x. So this will be 3 minus 2. Sorry, that will be 3x minus 2. 3x minus 2 plus what is common here? 1. 3x minus 2 is equal to 0. So this is 4x plus 1, and this is 3x minus 2 is equal to 0. So let's finish it up here. So this is 4x plus 1 is equal to 0. So x is minus 1 over 4, which is one of these, correct? So the next one, 3x minus 2 is equal to 0. So x is 2 over 3, which is this. So our solution is correct, but our option is not there, so they didn't write it there. Next question, find the quadratic equation whose roots are minus 1 over 2 and 3. Now, it's the same thing, okay? We are using variable squared minus sum of root variable plus product of roots equals to 0. But here, I'm going to give you the shortest way to construct a quadratic equation when you have the roots. So we know from the option that the variable is x. So I will say x is equals to minus 1 over 2 or x is equals to 3. So remember, this is over 1. So this times it, that is 2x is equals to minus 1. So 2x minus plus 1. That is what it means, because I'll bring minus 1 here, that will become plus 1. Then here, you have imaginary plus here. If you bring this one here, that is minus 3. So you just multiply both together. 2x times x, 2x squared. This times that, 6x plus x minus 3 is equals to 0. So 2x squared minus 5x minus 3 is equals to 0. So this is the fastest way to use the roots of a quadratic equation to construct the quadratic equation itself. So what is our option here? Our option is option C. Next question. We are given two roots, minus 2q and 5q, to construct the quadratic equation. And remember, the variable is x. So I will just x is equals to minus 2q. I will use the fast method, x equals to 5q. So x, bring minus 2q here, that is plus 2q. Okay, here, bring 5q here, that is minus 5q. Okay, so we multiply both together. It's equals to 0. So x squared, that is minus xq plus 2xq minus 10q squared is equals to 0. So x squared minus 3xq minus 10q squared is equals to 0. So our option is minus minus, then our option is option D. Now the next question. You are told that direction in each of these questions, two equations 1 and 2 are given. You have to solve both the equations and give answer. So question 1, the first one that we have is 21 over root x plus 11 over root x is equal to 7 root x. Okay, let's multiply through by root x. That means this over root x, we multiply root x. 11 over root x, we multiply root x. Okay, and 7 root x, we multiply root x. Root x we cancel with x. This we cancel here. So this is 21 plus 11 is equal to 7 root x squared. So 21 plus 11 is equals to 7. This we cancel this here. This is 7x. So and this is 32 is equals to 7x. So divide through by 7. So x is 32 over 7. Or let me press calculator here. So 32 divided by 7. So that is 4.57. That is x. Okay. Now let's check the second one. The second one says 2y squared minus 11y plus 12 is equals to 0. Okay, let's factorize this one. Okay, that is this plus 12 is equals to 0. So I can, this is 2y, this is y minus 4. 3 is common here, y minus 4 is equals to 0. So here 2y minus 3 and y minus 4. So y is equals to 3 over 2 or 4. So now let's compare x and y. Our x is 4.57 and our y is, I can still say this is the same thing as 1.5 or 4. And I can tell you now, you can see x is greater than both value of y. So in that case, our option is going to be A, if x is greater than y. Okay? If x is greater than y. That is going to be our option, which is option A. Now the next question 2, we're giving the first one to be 143x squared plus 43x minus 66 equals to 0. Let's solve this one first. Okay, we can easily factorize this. Okay, 66 equals to 0, so we can factorize this. What can go? That is 11. Okay, so 11 can go here. That is 11, that is 13. So 13x plus 11 minus 11 can also go here, or what can go there? 78. 6 can go here. That is 13. Okay, 6 can go there. So 6, it is 13x plus 11 is equals to 0. So 11x minus 6, okay, is equals to 0, and 13x plus 11 is equals to 0. Okay, so x is equals to 6 over 11, and x is equals to minus 11 over 13. Okay, let's put this one in decimal so we can actually see the figure. 6 divided by 11. So this is 0.54. This is minus 11 divided by 13. That is minus 0.84. That is for the first one. Now, let's do for the second one. Second one says 33y squared minus 40y plus 12 is equal to 0. So let's factorize this, okay? This is 22y plus 18 minus 18. That will be give me 40. So minus 18y plus 12. So what can go here? 11y. This is 3y minus 2. What can go here is 6, right? 6, that is 3y minus 2 is equals to 0. So 11y minus 6 equals to 0, or 3y minus 2 is equals to 0. So y is equals to 6 over 11, or y is equals to 2 over 3. So 6 over 11 is 0.54. Then 2 divided by 3, I'll press calculator for that. That is 0.66. 0.67. So now, you can see this value of x is equal to this value of y. And this value of x here is less than this value of y, because this value of y is greater. So what can we choose here? I will give you 3 seconds to think about it. Okay, so you see s is less than y, of course, right? S is less than y, but we have a value of x that is equal to y. 0.54, y is equal to 0.54, but there's a value of y that is greater. So our option is going to be C, if x is less or equals to y. Now, let's take the first question. If one root of the quadratic equation 6x squared minus x minus k is equals to 0 is 2 over 3. So one of the roots is 2 over 3. So let's say x is 2 over 3 because that is one of the roots. Find the value of k. Yeah, we've done something like this before. Remember, when you are given one root and it asks to find the other root, you just need to substitute the root given to you in the quadratic equation. So x is 2 over 3. So I will put x as 2 over 3, okay, to get k. So this is 6, this is 4 over 9, 2 over 3. Let's take k to the other side. So this is 24 over 9 minus 2 over 3 is equals to k. Here, I can say 3 here is 8, 3 here is 3. So 8 over 3 minus 2 over 3 is equals to k. So this is 3 here, this is 8 minus 2 is equals to k. So k here is 6 over 3, and that is 2. So the value of k is 2. You can confirm if you are correct. Just put the value of k. So 6x squared minus x minus k is 2 is equals to 0. So let's factorize this one, okay? So if I factorize this one, this is 2x, this is 3x minus 2, and this is 1, 3x minus 2 is equals to 0. So this is 2x plus 1 is equals to 0, or 3x minus 2 is equals to 0. So here x is equals to minus 1 over 2 or 2 over 3. And you can see one of the roots is 2 over 3. And the other root is minus 1 over 2. But we are not asked to find the other roots. We are just confirming, proving that we are correct. Now, the next question. Find the value of k for which one root of the quadratic equation kx squared minus 14x plus 8 is equals to 0 is 6 times the order. That means one of the roots is 6 times the other roots. Let's assume that the roots of the equation is alpha beta, right? And one of these roots, let's say alpha, is 6 times the other roots. So 6 times beta, because beta is the other roots. So here, the roots are now, what is alpha is the root, yes, but alpha is something as 6 beta. So rather than writing alpha, alpha is now 6 beta, then the other root is beta. So this is the new root now. You can see that one of the roots is 6 times the other one. So that is that. So here, what is our A? Our A is K, our B is minus 14, our C is 8. So sum of roots. What is sum of roots? That is 6 beta plus beta, and sum of root is minus b over a. So this is 7 beta is equal to minus 14 over k. Okay, so here I can say my k is 14 over 7 beta, which is 2 over beta. Okay, that is k. Okay, that is when we use sum. Now let's use products. Products of roots. So product of roots is alpha times beta. So what is the product of this root? That is 6 beta times beta, and that is equal to c over a. So this is 6 beta squared is equals to c. What is our c? 8. What is our a? K. So my k is 8 over 6 beta squared. say 2 here is 4, 2 here is 3. So this is our k. Now you can see k value is here, k value is here. So we can equate the 2k value together. So 2 over beta is equal to 4 over 3 beta squared. Okay, this can cancel one of the beta. So this is 6 beta is equals to 4. Okay, so beta is 4 over 6 or 2 over 3. But remember, we are looking for k, so we can use any of this k value. We get the same thing. So using k is equals to 2 over beta. That is 2 divided by beta. And what is beta? 2 over 3. So that is 2 times 3 over 2. This can cancel this. So my k is equal to 3. And we are asked to find the value of k. For question 3, we don't have to do that because question 3 is the same way that we did question 1. So I'm not going to waste time to do that. Question 4, if the quadratic equation D has 2 equal roots, then find the value of p. Okay, so px squared minus 2 root 5 px plus 15 is equals to 0 has equal roots. Remember, 2 roots are said to be equal when the discriminant is equal to 0. So d is equals to 0. And d here is b squared minus 4ac. So that means b squared minus 4ac is equals to 0. So b squared is equals to 4ac. So 2 roots are said to be equal when b squared is equals to 4ac. So here, let's compare this with our quadratic equation. So ax squared plus bx plus c is equals to 0. So my a will be p, my b is minus 2 root 5p, okay, and my c is 15. So let's put the formula, let's put all this value here. B squared, what is b? Minus 2 root 5 minus 2 root 5p, okay, square. Then 4 times what is a? P, and c is 15. So this one means minus 2 squared times root 5 squared times p squared, just for you to understand that. So this is 60p. 15 times 4 so this is 4 times this square will cancel this one, that is 5 times p squared is equals to 60p. So this is 20p squared minus 60p is equals to 0. So here p, I can say 20p is common. So this will be p minus 3 is equals to 0. So 20p here, so I can divide through by 20p, so that will be how. So p minus 3 is equals to 0. So p is equal to 3. The next question, if 1 is the root of the equation ay squared plus ay plus 3 is equals to 0, and y squared plus y plus b is equals to 0, we want to find the value of ab. And we're told that 1 is the root of that. So that means y is equals to 1, because 1 is the root of this both equation. 1 is one of the roots of that. So it simply means wherever I see y, I put 1. So let's start with the first one. A bracket 1 squared plus a bracket 1 plus 3 is equals to 0. So this is a plus 3 is equals to 0. So this is 2a is equals to minus 3. So a is minus 3 over 2. Okay, let's put the same y as 1 in the other one. Y squared, that will be 1 squared, right? So 1 squared plus 1 plus b is equals to 0. So this will be 2 plus b is equals to 0. So b is minus 2. Now the question requires us to find ab. That is a is minus 3 over 2 times what is b? Minus 2. 2 cancel 2 here. So minus 3 times minus 1, that will be 3. So AB is 3. That is option A. Now the next question is, if the quadratic equation mx squared plus 2x plus m is equals to 0 has 2 equal roots, then the values of m are, it says it has 2 equal roots. That means the roots are equal. And for a quadratic equation to have 2 equal roots, it simply means b squared must be equal to 4ac. So let's get our a, b, and c here. So my a is 1, my b is 2, and my c is m. So what is b squared? That is 2 squared. 4 times what is a? 1. What is c? M. 2 squared is equals to 4m. So 4 is equals to 4m. So m is equal to 4 divided by 4, which is 1. So if m is 1, let's put it back in this equation. That is 1 squared. That is 1 x squared plus 2x plus 1 is equals to 0. So we can try to factorize this. This is x, this is 1, x, this is 1, this is plus, plus. So x plus 1 is equals to 0, or x plus 1 is equals to 0. So x will be minus 1 twice. So that will be x. Okay. So in this case, we are looking for the value of m, and we already got our m to be 1. And you can see here, x is equals to minus 1 twice. It says that they are equal roots. Okay, so that confirms that our value of m is 1, and that is going to be plus or minus 1. A. Now the next question, the root of the quadratic equation 2x squared minus x minus 6 is equal to 0. So we want to find the roots. I can just use factorization method for this one. So 2x squared minus 4x plus 3x minus 6 plus 0. So for those of you that have not seen my video on factorization method, click on the top right hand corner of this video so you see it. So this is 2x, this is x minus 2 plus 3x minus 2 is equals to 0. So 2x plus 3, x minus 2 is equals to 0. So 2x plus 3 is equals to 0, or x minus 2 is equals to 0. So here x will be minus 3 over 2, or 2. So minus 3 over 2, or 2. So our option is B. Now let's take the next question. The roots of the equation x squared plus x minus p bracket p plus 1 is equals to 0, where p is a constant, are. So in this case, we want to get the root of this equation, x squared plus x minus p bracket p plus 1 is equals to 0. So we are interested in getting the roots. But remember that we can use the roots to construct the quadratic equation back. So, and that is what I'm going to use. So remember that in constructing a quadratic equation using its roots, we use this formula. Sum of roots product of roots is equals to 0. So we are going to use the options to see if we can get this quadratic equation. Okay? So we are doing it in a reverse way. So the first option here says option A. Let's get the sum of roots. Okay? Sum simply means they are using the option A says this. Okay? So let's get the sum. Sum of roots. If I have this together, P plus P plus 1. This is 2P plus 1. We already see that the sum of roots should give us, because this is plus, the coefficient of x is plus 1. So the sum of roots should give us minus 1, so that the minus 1 we multiply minus to get this plus 1. So we are looking for sum of roots that will give us minus 1. Okay? But this sum of roots is not giving us minus 1. So I will not even bother to do the product. So let's go to B. B is minus P bracket P minus P and P plus 1. So let's do sum of roots here. Sum of roots, let's add minus P plus P plus 1. This is giving us 1. Remember, we need minus 1. So that minus 1 can multiply this minus to give us plus. So B also is not the option. Let's go, it's not the solution. Let's go to C. P, comma, minus bracket P plus 1. Let's do sum of roots. Okay? So that is P minus P minus 1. So this is minus 1. Okay? So sum of roots is minus 1 here. So if I put minus 1 here, that is minus 1 times minus, this is plus x. So that is correct for sum of roots. But we need to confirm the product also. Product of roots. So product of root means P, we multiply minus P plus 1. Okay? So this is minus P bracket P plus 1. So if I put minus P bracket P plus 1 here, okay, that will give us this. So it simply means that option C is correct in terms of sum of roots giving us plus 1 and product of roots giving us minus P bracket P plus 1. So our answer, our solution here is option C. Now, next question, we are also looking for the root of this quadratic equation. X squared plus 5x minus alpha plus 1 and alpha plus 6 is equal to 0. It's just like the previous question, okay? So we are going to use the option to see which one is going to give us sum and which one is going to give us products, okay? So I'm just putting the formula here as we already know. So let's start with option A. Option A, alpha plus 1 and alpha plus 6. Let's do sum of roots. So alpha plus 1 plus alpha plus 6. This is 2 alpha plus 7. But sum here, because x is x, sum here should give us plus 5. But our sum here is giving us 2 alpha plus 7, which is not plus 5. So option A is wrong. So we already know that sum is wrong, so we don't have to do product for A. So let's go to B, option B. Option B is alpha plus 1 and minus alpha plus 6. So let's do sum of roots. So this will be alpha plus 1 minus alpha minus 6. Okay, alpha we cancel alpha, plus 1 minus 6, that is minus 5. And if I say minus 5 times this minus will give us plus 5x. So this is still correct for sum. So let's do product now. Product of roots. Product of roots will be minus alpha plus 1 and alpha plus 6 minus alpha plus 1 minus alpha plus 6. If I multiply that with this minus and plus, it will still be minus alpha plus 1, alpha plus 6. So which simply means for product and for sum, we got the same thing. So if I put it here just to confirm, okay, x squared minus sum of roots is minus 5. X, product of root is minus alpha plus 1, alpha plus 6 is equals to 0. So this is x squared. If I minus times minus plus 5x minus alpha plus 1, alpha plus 6 is equals to 0. So which is the equation given to us? So the root of this equation, the option is B. Now, next question. The root of the equation x squared minus 3x minus m bracket m plus 3 is equals to 0. So here we are looking for the root of the equation. It's still the same thing with previous that we have done. So let's try option A. Option A is m plus 3. So here we know sum of roots, that is m plus 3, that is 2m plus 3. And you know our sum of roots must give us minus 3. But in this case we have 2m plus 3, so we don't have to do the product, so A is wrong. Let's go to option B, minus m bracket m plus 3. Okay, so sum of roots here, that is minus m plus m plus 3, minus with this, that is 0. So this is 3 here, right? And remember our formula is x squared minus sum of roots x plus product of roots is equals to 0. So if our sum is 3, if I put 3 here, that is minus 3x, which is still equal to this one here. So that means sum, that means this is still correct for sum. So let's quickly do that for products, okay? For product of roots, that will be minus m bracket m plus 3. And if I multiply minus m bracket m plus 3 times this plus, that will still be minus m bracket m plus 3. So our answer here is option B. But to check, we can just put it inside. X squared is x squared minus sum of roots, we got 3, that is 3x, plus product of roots is minus m bracket m plus 3 is equals to 0. This is x squared minus 3x minus m bracket m plus 3 is equals to 0. You can see now this is equal to the equation given to us. So option B is correct. Now the next question says find the discriminant of the quadratic equation 3 root 3x squared plus 10x plus root 3 is equals to 0. When you are talking about discriminant, our discriminant D is equal to B squared minus 4AC. So now we need to find our A, B, and C. Our A in this equation given to us is the coefficient of x squared, that is 3 root 3. Okay, our B is the coefficient of x, which is plus 10 or 10, and our C is root 3. So our D, which is discriminant, is B squared. Our B is 10 squared minus 4AC, 4 times A and times C. So this is 100 minus 4 times 3. Root 3 times root 3 is 3. So this is 100 minus 4 times 3, that is 12. 12 times 3, that is 36. So 100 minus 36, that is 64. So our discriminant is equal to 64. Now the next question says write the nature of roots of quadratic equation 4x squared plus 4 root 3x plus 3 is equal to 0. Now, we want to state the nature of the root of this equation. Whenever we are asked for the nature of the root of a quadratic equation, we use discriminant. Discriminant is equal to b squared minus 4ac. Now, when your discriminant is less than 0, that means the roots are complex roots. When your discriminant is greater than 0, it simply means the roots are different and real roots. Okay? When your discriminant is equal to 0, it simply means the roots are equal and real roots. So, these are the conditions, are the nature of roots. So, in this case, we need to check what we have here. What is our A? Our A is 4. What is our B? Our B is 4 root 3. And what is our C? Our C is 3. So let's find the discriminant. Discriminant is equals to b squared minus 4ac. My b is 4 root 3 all squared minus 4 times 4 times 3. Okay, so this is something as 16 times 3, because that means 4 root 3 times 4 root 3. 4 times 4, 16. Root 3 times root 3 is 3. So here, 16, this is 4 times 4, 16. Okay, 16 times 3, that is 48. Okay, so 48 here. This one also is 48 minus 48. That is equal to 0. So in this case, our D is equal to 0. And you know, if D is equal to 0, what is the nature of the root? It is equal and real roots. So that is our answer, equal and real root. Now the next question, for what value of k the quadratic equation x squared minus kx plus 4 is equal to 0 has equal roots? Remember, for a quadratic equation to have equal roots, it simply means discriminant must be equal to 0. And we know our discriminant is b squared minus 4ac. So b squared minus 4ac must be equal to 0 for equal roots. So now here we need to get our a, our b, and our c. So our a is the coefficient of x squared here, which is 1. Our b is minus k, and our c is 4. So let's put this value here in b squared minus 4ac. So minus b minus k all squared, that is b squared, minus 4 times 1, which is a, and c is 4, is equal to 0. So this is k squared minus 16 is equal to 0. So k squared minus 16 is the same thing as difference of two squares. Okay, so I can just tell you that I can write it like this: k squared is equals to 16. So k is square root of 16. K is plus or minus 4. So which simply means k is 4 or minus 4. So that is the value of k. The next question, what is the nature of the roots of the quadratic equation 4x squared minus 12x minus 9 is equal to 0? So here, remember, for you to get the nature of a particular root, we use discriminant. Okay, so and discriminant is equal to b squared minus 4ac. So we need to get our a, we need to get our b, and our c. Our a here is 4, our b is minus 12, and our c is minus 9. So let's get the value of the discriminant. So d is equal to, what is b? minus 12 all squared minus 4ac, 4 times 4 times minus 9. So this is 144 minus times minus is plus 16 times 9. I'm going to use my calculator. 16 times 9, that is 144. So this is 144. And 144 times 2, that is 288. So in this case, our D is 288. Remember, for the nature of roots, is either D is less than 0, or D is greater than 0, or D is equal to 0. For D less than 0, the roots are said to be complex roots. Okay, for D greater than 0, the roots are said to be different and real roots. Okay, for D equals to 0, the roots are said to be equal and real roots. So in this case here, our D is greater than 0 because it's 288. So the nature of our root is different and real roots. Wow, congratulations, you were able to stay to the end of this video. My next video is going to be solving quadratic equation using the graphical method. Hope to see you in the next video. Bye for now.